wabarakatuh. Today, inshallah, we're going to solve question number 15 from topic 1, measurement and uncertainty IB practice problems, paper 2. Here we have a student investigates the oscillation of a horizontal rod. So here we have a horizontal rod that's hanged with a string. Here we have a vertical string and it's hanged. The rod at the end of a vertical string, the diagram shows the view from above. So if we look from above, the rod will oscillate back and forth. Okay. The student start the rod oscillation and measures the largest displacement for each cycle of the oscillation on the scale and the time at which it occurs. The student begins to take measurements a few seconds after releasing the rod. The graph shows the variation of displacement x with time t. Since the release of the rod, the uncertainty for t is negligible. So here we have relationship between displacement and time. Displacement in centimeter, time in second. On the graph above, draw the line of best fit for the data. Line of best fit not necessarily to be a straight line, but since we have error bars, so we can draw smooth curve that passes through all the error bars. So all we need to do is just draw a smooth line that passes through all the error bars. Smooth curve. Okay, B, on the graph above, draw the line of best fit. Next, calculate the percentage uncertainty for the displacement when t is 40. Okay, so when t is 40, the value of displacement, okay, this value here, you can go and read the value here. Now from 0 to 2 is 2 divided by 5 squares. So 2 divided by 5, it will give us 0.4. So each square in the vertical direction will represent 0.4. Here we have around 2.5 square, 2, okay, 2.5 times 0.4 to give us 1. So this reading here is 3. 2 plus 1 is 3. So the value x naught at t equals 0 will be 3 centimeter. Now, the uncertainty in the displacement is the length of error bar. Here we have it's less than, on the top, it's less than 1 square and it's around half a square. So it will be half a square and 3/4 of the square. Okay, so it will be around 1.25. 1.25 times each square we said is 0.4. So 1.25 times 0.4 will be around 0.5 centimeter. How did I calculate this one again? The length of error bar, the distance from here till here from the top. You have this point. This will be delta x from top and bottom. Now delta x, the length of the error bar, it's around, when we calculate it, is around 1 and around quarter square. 1/4 square. Each square we said is 0.4. So 1 square, 1 1/4 square times 0.4 will give us 0.5 centimeter. Now we need the percentage uncertainty. Percentage uncertainty, it's the uncertainty, absolute uncertainty, divided by the original times 100% times 100%. So the uncertainty is 0.5, the length of the error bar, divided by the original 3 times 100%. This will be around 16.6, so it's around 17%. Now, if you got values between 15 and 25, you're on the safe side, between 15% and 25%. See now, the student hypothesizes that the relationship between x and t is x equals a divided by t. Displacement equals a times 1 over t. Now here we have a relationship between displacement in centimeter and t inverse. T inverse, it means 1 over t. 1 over t. So if this is in y-axis, this one in x-axis, A will represent the slope. Okay. Now to test the hypothesis, x is plotted against 1 over t. If we get straight line, if the relationship between x is directly proportional with 1 over t, that means I should get straight line. The straight line not necessarily to pass through all the points, at least 3 points, and it should pass through the origin. Okay. Now the question is, at data point correspond to t equal 15 has not been plotted. Plot this point on the graph. Okay. At t equal 15, that means 1 over t. At t equal 15 second, 1 over 15 will be 0.07 second inverse. Now here, from 0 till 0.05, I have 0.05 distance divided, I have 10 squares. So each square on the x-axis will represent 0.05 divided by the number of the squares, 10. This will equal 0.005. Okay, so 0.005. Here I have 0.5 and I need to go to 0.05. That means I need around 4 squares to reach 0.04. But before, we have to draw straight line with a ruler. Don't use your hand. You have to use a ruler. The line should pass through the center, the origin, and at least 3 points. Okay, at least 3 points. Now at 0.04, 0.07, that means 4 squares. So you count 1, 2, 3, 4. This will be 0.07. And you draw a vertical line. And then till it touches the line that you draw, and then you go and read this value here. Okay, now here on the vertical line, I have 2. This one here, I have 2 divided by the number of square 5. So each square will represent 0.4. 0.4. And here we have around 2.5, 2.5 square times 0.4. This will give us 1. So this value here is 9. So the value of x will be 9 centimeter. 9 centimeter. This point here. So the point x and y. X is 0.07. This is the value of 1 over t. And y, the value of the displacement is 9 centimeter. Suggest the range of values of t, which the hypothesis may be assumed, so that means it could be wrong. But if we assume the hypothesis is correct, which means X is directly proportional with 1 over T, with 1 over T. So this range should go from the smallest value here of 1 over T, this value, the smallest one, which is around 0.025, it's half of 0.05, and this value here, so these two values, the line will pass through, we should get straight line that pass through the origin and pass through these two values. So this is 0.05, this is 0.025, and this value is around 0.04. So the value of 1 over T, the value of 1 over T, it will range between 0.025 till 0.04 second inverse. Okay, that was the solution of question number 15.